Hello guys, welcome back to the CCNA routing and switching video series. In this video, we will be having a look at VLANs. The main objectives for this video are to understand what VLANs are and why do we need to use VLANs. So before we dive into what VLANs are, let's understand why VLANs were created in the first place. So we use VLANs for two reasons: network security and broadcast traffic. So as your network grows, you will get more and more and more broadcast traffic on your network. Now, broadcast traffic, if you have enough devices, can be detrimental to network performance. The story goes something like this. You are a new company. You open up a new office. You may have 10 users on your network at first. Not many users. Broadcast traffic will not impact network performance. However, as your network grows, you get 10 users, 100 users, 1,000 users. So essentially, now you have 1,000 devices on your network. Each one of those devices, they will be generating broadcast traffic. And just so that you know, broadcast traffic generated from one device will be sent to all other devices which reside on that network. That means that every device on your network has to spend some resources, some time processing that broadcast packet. And if broadcasts get too large, if we have too many broadcasts on our network, that could impact network performance, because your computers are spending so much time processing broadcast packets that they run slowly. The links are going to be congested with broadcast traffic. So not only is the link running from your computer to your switch going to be congested with broadcast traffic, but also the links running between your switches will be congested with broadcast traffic as well. So if we have too many broadcasts, it can effectively kill our network and can be a detriment to network performance. The other issue we have is that with switches represent one broadcast domain, one network. So in this case, if we have devices which connect to a switch, they'll be part of the same IP network. If we have switches connected to each other and we have devices connected to the other switches, they will also be part of the same IP network. Now, devices in the same IP network, they can communicate with each other directly. Now, you may be thinking, well, that's the whole reason why I build a local area network. It's so that devices can communicate with each other directly. However, within an organization, we just don't want to have a device being able to access anything. The reason being, because usually an organization is divided up into departments. Now, obviously, we'll have a HR department, a legal department, and an IT department. And so the way that actually works is that there are certain resources that a department doesn't want other departments to be able to access. As an example, imagine that the accounting department has a payroll server. Now, users from the sales department or users from the IT department shouldn't be able to access that payroll server. The problem is, at layer 2, that unless you expend a lot of money on a high-end switch, there's not very many features that we can use to kind of control what devices can access what devices. And worse yet, imagine if we had some guest users connect to our network either via the Wi-Fi or via a wired connection without VLANs, or without having some way to segment that traffic and keep that traffic separate. They would be able to access anything on our network, which again is a security risk. So without VLANs, this is the issue we have. We have devices which connect to our network, which connect to our switches, being able to access any other device. And we also have very large broadcast domains, meaning that we'll have thousands of broadcasts per minute. Our computers will have to process those broadcasts, meaning they will run more slowly, and meaning our links will be congested with broadcast traffic. Now, how do we resolve this? Well, one way that we could resolve this without VLANs is to actually build a separate network for each department. That way we could obviously maintain that the broadcast domains would be small, because your departments may be limited to, let's say, 100 people, 200 people at the very most, if you are a smaller organization. And this also ensures that we deal with the security aspect, because obviously that means that users part of the HR department can access the devices within HR, the servers within HR. And obviously devices within another department, because they're on a completely separate network, will have to go through a layer 3 device to be able to access that. However, that costs money. It costs money to obviously upgrade our links to faster speeds, and obviously essentially set up a completely different network for all other departments. It's going to be a hell of a lot of money. Is there an easier solution to this problem? And that solution is VLAN. So VLAN, it stands for virtual LAN. So Remember, one switch equals one network or one broadcast domain. So what VLANs allow us to do, they allow us the ability to take that one switch and logically divide that switch into multiple IP networks or multiple broadcast domains. And the way that we do this is that from that one switch, we would assign different ports on that switch or different ports on multiple switches to different VLANs. So one VLAN equals one network. So if we configure 10 VLANs on a switch, we would have 10 different IP networks on that switch. And so with a virtual LAN, we are logically separating devices into different subnets, different IP networks. And all devices will still connect to the same switch, to the same network infrastructure. So we can have the physical network infrastructure stays the same, but logically we can then divide the switch into multiple IP networks. And this resolves both of our issues. So this resolves the security issue in that we can actually group devices based on departments. So we could have HR being assigned one VLAN, sales being assigned one VLAN. The salespeople can communicate with each other, but if they want to communicate with the HR department, they'll have to go through a layer 3 device, which means that we can implement some security policies. And also by using VLANs, we can then make our broadcast domain smaller. So we could limit our broadcast domain to, let's say, 200 devices, meaning that each device has to process less broadcast, also meaning that our links are less congested with broadcast traffic as well. So like I said before, we're taking a single switch and we are dividing that switch into multiple different IP subnets known as VLANs, and we do this by assigning different ports on that switch to different VLANs. And so the devices in the same VLAN are part of the same broadcast domain and can communicate directly. Devices in different VLANs are in a separate broadcast domain, different IP network, and have to go through a layer 3 device in order to communicate. And devices can be connected to the same network regardless of the physical location. So we could have devices in 2 separate buildings be part of the same VLAN and therefore be part of the same IP network. So with VLANs, this is what we're doing. We're taking that switch and we're dividing that switch into different VLANs, different IP networks. So in this case, we would assign the sales devices into the blue VLAN and the IT devices into the red VLAN. Now obviously, because they're in different VLANs, it means they're in different IP networks. In this case, the sales VLAN, they would be part of the 10.1.1/24 network. The IT devices may be part of the 192.168.200/24 network. Now, the sales device cannot communicate directly with the IT devices or the devices part of the red VLAN. They would have to go through a layer 3 device. This also helps limit our broadcast domain as well. So in this case, a broadcast sent by a device in the blue VLAN will only be sent out ports which are part of the blue VLAN. So in the case, this VLAN, this port, this port, this port, this port, and this port. And in this case, broadcast traffic isn't even sent to this switch. The reason being because there are no ports on that switch assigned to the blue VLAN. Again, this can reduce the broadcast traffic on our links because broadcasts are not flooded to any switches which do not support that VLAN or which do not have any ports assigned to that VLAN. And so with VLANs, we can group devices, and usually you will group devices based on department. So you may have one VLAN for the sales department, one VLAN for the legal department, one VLAN for the HR department. Or what you can do, you can group devices based on the function. So you may have all IP phones in one VLAN, all corporate users in one VLAN, all guest users in one VLAN, and all servers in one VLAN. And because they're in separate VLANs, it means that in order for them to be able to communicate, they will still have to go through a layer 3 device, meaning we can still implement some sort of security policy. And the VLANs, they can span multiple switches. So we could have the red VLAN, like in this example, span 2, 3, 4, or 5 switches, and no matter what switch a device connects to, if they're in the red VLAN, they will still be in the same IP network. Now the question comes into play. How do we get traffic from one VLAN to another VLAN? So how do we send traffic in from one VLAN on one switch to a device in that same VLAN on another switch? The two options that we can use. In this case, we can actually have a link running between both switches. One link which is in the red VLAN and one link which is in the blue VLAN. This means any traffic, in this case, let's say a device on this port wanted to communicate with a device on this port, the traffic would flow over this VLAN, over this link, and would be sent out this port. If we wanted a device which connects to the red VLAN to be able to communicate with a device in the red VLAN on this switch, we could then use this port. So what we can do is that we can essentially assign a link or interface to each VLAN. Now this would be okay if we had 1 or 2 VLANs, but it doesn't scale well if we had 100 VLANs or 1000 VLANs. Essentially, we would need to have an individual port for that VLAN on each switch. The better solution is to use what we call VLAN trunking. So with VLAN trunking, we configure a trunk link or a tag link between our switches, and that trunk link can carry traffic for all VLANs. The way that it does that is that before the sending switch sends the Ethernet frame onto the trunk link, it's going to attach a VLAN tag, and that VLAN tag denotes to which VLAN that frame belongs to. So as an example, if a device in the blue VLAN over here wants to communicate with a device in the blue VLAN over here, before this switch sends that Ethernet frame over that trunk link, it will attach a VLAN tag to tell the receiving switch this frame belongs to the blue VLAN. This makes sure that when the switch receives this frame, it will only send that frame to devices in that blue VLAN. So let's have a look at more info about VLANs. So VLANs, they're not actually identified by numbers or colors, so by colors. They're identified by numbers. The reason why I use colors in the previous example, because it's easier to see how we can group devices based on colors. So as an example, the devices in the blue VLAN can all communicate together. They'll be in one IP network, and then the devices in the red VLAN will be in a separate IP network. But it's important to keep in mind that logically they're separated, but physically they still plug into the same switches and still communicate over the same links and over the same network devices. But logically we can divide that switch or those switches into multiple separate IP networks, multiple separate VLANs. And when we can configure VLANs, we can give it a descriptional name. So we can give it a name such as finance VLAN, sales VLAN, so that we know what that VLAN is used for. And like I said before, is that with VLANs we can have two devices which are in two completely different geographical locations, and they could connect to the same network and access the same resources if we assign the switch ports they connect to into the same VLAN. And by default, the default VLAN on a Cisco switch or HP switch or Juniper switch is VLAN 1. So the VLAN feature is always enabled on a switch. And that comes into play is that what VLANs are configured or what VLANs are set up on a switch which is fresh out of the box, and the answer is VLAN 1. And all ports are assigned to VLAN 1, so all ports are part of the same IP network, part of the same broadcast domain. So like I said before, a trunk port works. So the sending switch will insert a VLAN tag into the frame, telling the receiving switch to which VLAN this frame belongs to. And the receiving switch will see the VLAN tag and look in the MAC address table for that specific VLAN. So as an example, if the sending switch inserts a VLAN tag of 10, the receiving switch will know, okay, so this frame belongs to VLAN 10. I can only send this frame to devices in VLAN 10. So when I search my MAC address table for an entry for the destination MAC address, I will only look at the VLAN 10 entries. And so switches can use two methods or two different protocols for tagging Ethernet frames. ISL, which is the newest, this is a Cisco proprietary protocol, or we can use the vendor neutral protocol 802.1q or .1q. So the way that .1q works, we insert a 4-byte VLAN tag into the frame. That 4-byte VLAN tag has a field which identifies the VLAN to which this frame belongs to. That VLAN ID field is 12 bits, which means that we can have 4,096 VLANs configured per switch. The other fields within that tag are the TPID or the tag protocol identifier, and this is set to 0x8100, and this is to identify the frame as a .1q frame is 16 bits in length. We have the priority field, which is 3 bits, and this allows for class of service. This allows us to treat certain traffic better than others and provide a better quality of service. C of I field is 1 bit and identifies if the MAC address is in canonical or non-canonical format. Then we have the VLAN ID, like I said before, is 12-bit field to identify to which VLAN this frame belongs to. We also have the concept of the native VLAN. So the native VLAN just tells a switch that if it receives a frame over a trunk link which doesn't have a VLAN tag, to which VLAN this frame belongs to. And so the trunk link is a feature which is configured on both ends of the trunk link, so on both trunk ports of a Cisco switch. And obviously the native VLAN has to match on both ends, because what may happen is that if a device, in this case, let's say that the native VLAN is set at 10 on this switch, if the switch is going to forward a frame out and that frame was received by a device in VLAN 10, it's not going to attach a VLAN tag, because all frames part of the native VLAN are sent out of a trunk link untagged with no VLAN tag attached to it. If this receiving switch is configured with a native VLAN of 5, it means that when it receives the untagged frame, it's going to assume that that frame is part of VLAN 5, and then that frame will not be delivered to the host at all. So it's very important that obviously both sides of the trunk link are configured with the correct native VLAN, and also that we use an unused VLAN. The reason being is because if we set up the native VLAN to be a VLAN which is used for access ports, so for ports, access ports, or ports which are part of one VLAN and connect to a single device, if we use a native VLAN that is used for access ports, it may result in something called double tagging, which is a vulnerability or an attack that a hacker can do, in which he moves from one VLAN to another VLAN without going through a layer 3 device. And that's all there is to it. VLANs are already that simple. So we're taking our switch, we're logically dividing our switch into multiple IP networks, multiple IP broadcast domains, by assigning certain ports on that switch to different VLANs. So that means, let's say, ports assigned to the blue VLAN cannot communicate with ports assigned to the red VLAN. And that can span multiple switches. I hope you have enjoyed this content. If you have, then please subscribe to my channel. If you find this video useful, then please share, so that we can get high quality IT training to the masses free of charge. Thank you for watching.